All right, here we go. Our objective for today, I can add and subtract polynomials. Read together. 1, 2, 3. I can add and subtract polynomials. So if you notice, we're still on the same concept, polynomials, and they're not going to go away from this point forward. Like I said, this is going to be here all year, next year, and the following year, and the following year, and the following year. So you need to get used to these, okay? So, polynomials. Essential question for today. What happens to the exponents on the variables of like terms? What happens to the exponents on the variables of like terms? Elaborate. So in your Fourier model, polynomials. Think about the definition. One of the questions from last night home plate, they were asking you the definition of polynomials. So think about it. What are polynomials? And write it in there, please. Go. All right, it should look something like this. They are monomials, or sum and difference of monomials. And like I said, that was in last night's home play, right? Yes, Mr. Q. All right, good. Examples, non-examples, and we know that they're expressions only with various terms. Copy these steps down, please. Step 1, distribute, multiply factors to each term inside the parentheses. Step 2, identify like terms. Step 3, use commutative and associative properties to combine like terms, which is add or subtract. And step 4, simplify. Copy that. And these steps we're going to keep using to combine like terms. And today we're going to look at that. Okay? So, really quick, to do a quick intro in regards to combining like terms. Watch. We got this, we got this. Okay. So, pens down, eyes up here. So, like I said before, from this point forward, we're going to see polynomials. You're going to see them almost everywhere. And let me show you a quick application. So, let's say I wanted to open up a store, and you guys were going to be my employees, right? In that store, we're going to sell pets. So, here's my store. Mr. Q's Pet Shop. 760 Mr. Q's Pet. What street? Bam. So, in that store, we're going to sell, well, I have a Siberian Husky, so we're going to sell Siberian Huskies. Also, to not leave people out, we're going to sell cats. Also, we're going to sell dolphins. And we're going to have money. Okay? So that's what we're going to have in that store. And, of course, I have to go on trips so I can go get, like all these pets brought into the store and order them, but I need to go see them to make sure that they're good quality and stuff, right? So I need to leave people in charge. So I'm going to leave the store in charge to Shayna, and how about Joel? So they're the ones in charge. So if people get out of line, smackety smack, right? So there are my floor managers. The rest of you, you guys are my peons. So you guys are going to be like picking up the poop and cleaning the store, washing the fish tank. Somebody said earlier, Mr. Q, what happens when the dolphins poop? Where does it go? I'm like, it stays in the water. Anyways. So whoever's going to be cleaning the tanks, there you go. So this is how easy I can present polynomials. Here it goes. I'm going to call from LA when I go get my order, and I'm going to ask whoever picks up from my floor managers to write down the order. So phone ring. Joel picks up. He's all, hello? I'm like, hello? You're supposed to say Mr. Q's Pet Shop. All right, fine. So I'm going to send a truckload of animals and some money. So write this down. He's like, all right. So he gets a pen out. No, this is him, not you guys. Right? So Joel has to write this down. So I ready? Yes. Okay, I'm sending you 8 dogs, 10 cats, 3 dolphins, and $1,000. And the second shipment is 12 dogs, 6 cats, 1 dolphin, and $23. He's all, wait a minute, Mr. Q, I'm falling behind. Well, you wanted to be the manager, it goes with the job, right? More responsibility, more pressure. But then he's like, well, can you help me so I can write it a little bit, slow down? I can't slow down, but I'll show you maybe a shortcut on how to, instead of writing the entire word for dolphins, you see what I'm saying? It takes longer. So instead of doing all that, I said, all right, Joel, for dogs, whenever I say dogs, you're just going to write x squared. For cats, you're going to write y. For dolphins, you're going to write q cubed. And for money, you're just going to write the number that I give you. So here we go. Here it goes again. First shipment, 8 dogs. What do I write? 8x squared. 12 cats. What do I write? 12y. 4 dolphins. What do I write? 4q cubed. And $1,000, so that's 1,000. Second shipment, 7 dogs. What do I write? 7x squared. 2 cats. What do I write? 2y. 1 dolphin. 1q cubed. And $23. All right? So then I say, all right, Joe, read me back everything that I just gave you, but put them together. How many total dogs do we have? Everyone. 15, and he's going to say 15x squared. How many total cats? 14y. How many total dolphins? 5q cubed. And how much money do we have? 1,023, my God. So does everybody see what we just did? That's combining like terms. I cannot combine 15x squared with 14y because why? These are dogs and these are cats. Now, who noticed that here we don't do anything to the exponent? We just bring this down if it's the same. Did everybody notice that? Same thing here. These are the same. We just bring it down. And what do we worry about now only? The number in front of the variable. What is 8 plus 7? 15. What is 12 plus 2? 14. What is 4 plus 1? 5. Everybody see how that works? And that's an easy way of introducing combining like terms in polynomials. Okay? The second way is using algebra tiles. So get those tiles out of the baggie, please. All right, first things first. I want you to get in front of you a yellow tile. Put it on the paper, like so. Then I want you to trace it with your pencil. All right, so label the base 1, and the height is 1. So if I was to ask you what is the area for that square, you were going to say 1 times 1 is 1. So from now on, whenever I ask you to get 1 in front of you, 1, you're going to get a yellow small square. Everybody following? But if you notice, if you reverse it, what color is the reverse? Red. So that means that's -1. Red is a negative. So whenever I say -1, we're going to get a red square in front of us. So far, so good? All right, next, I want you to get a green rectangle in front of you. Trace it, please. So we trace this. So what would we label the base on that, the rectangle? What would we label it? 1, because it's about the same size as the rectangle, the square, right? What would we label the height? What do you guys think? Do we know exactly what the height is? No. So since we don't know, what can we label it? X. So the area, what is 1 times X? X. So from now on, when I ask you to get an X out, you're going to get a green rectangle. How about when I say get a negative X out? What would you do? Get a red rectangle out, which is just flipping it, right? Does everybody understand what we're doing? Okay. So, next, get a blue one in front of you. Go ahead and trace that. Once you trace it, what can we label the base? Do we know? We don't know, so what can we label it? X. So what is the height if it's a square? X. So what is X times X? X to the second. Whenever I ask you to get an X square out, X squared, you're going to get a blue one. But how about when I ask you to get a negative X squared? It's going to be a what? A big red. So basically you just flip it. Everybody with me? All right. Do we know now the names of these tiles, right? And how to use them? So, let's see if it's true. I'm going to clear this up. Clear your desk. You should have it blank. Let me get another blank sheet. So, on your desk in front of you, this is what I want you to show me. Show me x squared plus 5x plus 6 using the tiles. Show me x squared plus 5x plus 6 using your tiles. Show me that, please. Go. All right, check with the neighbors, see if they have something similar to yours. Look over. So let's see. 1x squared should be a blue one, is that correct? And then from there, 5 green ones. And then from there, 6 yellow ones. That's it. That pretty much looks like yours, something like that? Yeah? All right. We're getting the hang of this? Yeah? Okay, slide those up a little bit, so like that out of the way. Now I want you to show me negative 2x squared minus 3x minus 2. Go. Using tiles. If it doesn't look like yours, your neighbors, help them out. So, negative 2x squared, that means 2 red ones. Is that correct? Then from there, negative 3x, that's 3 red rectangles. And negative 2, that means 2 small of the squares. So far so good? Yes? Hands if yours looks like that. Okay, so now that we got the hang of this, yes? Okay, let's slide this over. So on your paper, I want you to copy this next one and write example Q. Example Q. You're going to write on your paper x squared plus 5x plus 6 in parentheses plus, open parentheses, negative 2x squared minus 3x minus 2, close parentheses. Okay? So once again, now that we know what each one is, you're going to show me this one using tiles right here, And then underneath that, you're going to show me the other one using tiles. Go. Okay. Check over with your neighbor, see that they have something similar to yours. Look it over, see if they're missing anything. So let's see. Your neighbor should have one blue one, 5 green ones, 6 yellow. Is that correct? So far, so good? Then from there, they should have 2 red ones of the big ones, 3 red of the rectangles, and 2 red of the small squares. Hands if you got that so far. Okay. Well, now check this out. What we're going to do right now, look up to the screen, please. Pens down and leave your tiles for right now. Look up to the screen. What we're going to do now, we're going to combine like terms using tiles. Now, how do we do that? What was the first property that we introduced at the beginning of the year? The additive inverse property. What was that called? 0 pairs. Remember that? So watch. We're going to do 0 pairs using these tiles. Look up. I have 2 negative 1s here. Can they make a 0 pair with 2 positive 1s? Yeah, there's a 0 pair right there. So get those together on yours. What else becomes a 0 pair? Yeah. 3 of the red ones of the rectangles and 3 of the positive ones of the rectangles. Everybody see that? This is another 0 pair. Okay. And do you see one more 0 pair? Yeah, which ones? The blue and the red are the big ones. This one and this one are the 0 pair. And what's left over? Let's see. What do we have left over? What is this one? Negative x squared, and this one? Positive 2x plus 4. So check this out. So if I was to write that out, look up, please. Watch. Once we combine everything, all this becomes, I'm going to write it right above, negative x squared plus 2x plus 4. All this, these two combined become this. Are we there? So now, let me show you how it works on paper. Check this out. On paper, what did we do on this side? We placed all the big squares together, didn't we? So I'm going to write this big square and these 2 big squares together. See how that worked? Next, I got all the rectangles together. So this one and this one together. So I'm going to write plus 5x and negative 3x. Then at the end, I got the little ones, this one and this one together. So I'm going to write plus 6 minus 2. So let me ask you a question. When we have numbers and variables like this and we move them around to rearrange them, what property is that called? Everyone? Commutative. That is the commutative property. However, what is the next step? We do this to simplify it. So what is that called when we group them? Everyone? Associative property, and both of them for addition. All right, so now check this out. What did we get at the end? Negative x squared. So pay attention to this part. Negative x squared. So look, here's x squared and here's x squared, and I only wrote it once. Look, what is the coefficient of this one? 1. And what is the coefficient of this one? Negative 2. And what did we get at the end? Negative 1x squared. So what can we conclude? That for when we're combining like terms, what happens to the exponents? Nothing. They stay the same. We rewrite it, and we just combine coefficients. Does everybody see that? Look at this one. X and x. I rewrite it. What is 5 minus 3? 2. Okay. And what is 6 minus 2? 4. Copy that, please. And move this out of the way. So, look up, please. Really quick. So, like terms means that they need to be the same kind. Did I show you that with pets? Yes, I showed you that with tiles. Now, let me show you just with numbers. A constant is just a number without a variable, like the 35 and the negative 12. A variable or variables are the same kind if they have the exact same exponent. So watch. X squared and x squared are the same. X and x are the same. So therefore, those are like terms. Does everyone understand? So, and did we combine them? So here, in order to combine, we move stuff around, and what properties did we use? The commutative and the associative. Everybody got it? So, our home plate for tonight, home plate, is found on pages 488, and you're going to do numbers 8 through 9, 489, then you're going to do numbers 13, 15 through 18, and page 490. Yes? All right, put away my tiles, exit out of your presentation. Have a good one, guys. There's tutoring today. Once again, you're welcome to stay. If not, I'll see you guys tomorrow. Bye.